So as you can see, this tutorial is going to cover object pulling and infinitely spawning a ground similar to the Ghost Pop mobile game. If you haven't seen this or any of the other tutorials, check them out. A link will be in the top right hand corner. Also a disclaimer, I'm using the code from Bracky's tutorial on object pulling as I believe there's no point in reinventing the wheel, as well as this is not the main focus for the series. So I've left a link in the description for you to check out Bracky's tutorial because he'll probably explain it better. I will be showing you how to expand this for the ground spawning and in future enemy spawning, so let's jump into it. The first thing I'm going to do is I'm going to update my project version. So if you haven't, you can go to installs and you can click on add, and you can add the most recent install. I've already got it installed right here. Once it's installed, I'm just going to click the drop down and I'm going to click on the latest version, and when you click on open, it's going to say, do you want to upgrade your project to a newer version of Unity? So I'm going to click on confirm. Now the first thing I'm going to do when the project opens up is I'm going to create a new script. So I'm going to right click, create, C# script, and this is going to be object puller. So I'm going to open this one up. Once it's opened up, I'm going to remove this. And the first thing I'm going to do is I'm going to create a pull class that is serializable so we can edit it in the editor. So I can type in system.serializable, and below that I'm going to type in public class pull. So this is going to be our pull. We're going to have a public string, which is going to be our type of pull. And we're also going to have a public game object prefab, which is going to be the prefab object that we're going to be spawning from the pull. And we're going to have a public int of size. This size is going to be how many objects we're going to have in the pull of this type. Once that's done, I'm going to create an instance of this, so I can type public static object puller instance. And in our private void await, we're going to type in instance is equal to this. So we're going to set our instance to this object that's going to be attached to this script. Next, I want to create a public list of our pulls. So I'm going to type in public list of type pull. This is going to be our pull. We also want a dictionary. So I'm going to type in public dictionary. And the key is going to be a string, which is going to be our type. And we're going to store a queue of our game object. And I'm going to call this our pull dictionary. Every time we reference a type, it's going to grab our queue, and the queue will be able to initiate the spawning. Now we're using a queue because it is much more efficient than instantiating naturally. So if you want to expand your game to have hundreds and hundreds of different types of objects spawning, it'll be a lot more efficient for mobile, which is exactly what we want. I'm also going to have a game object called object to spawn. So we just need to keep a reference for that. Next, let's type in our void start. The first thing I'm going to do is I'm going to define the pull dictionary. So I'm going to make it equal to a new dictionary of type string and queue game object. Next, I'm going to type a for each. So for each pull in our pulls list, what we want to do is we're going to grab a queue of type game object, and this will be our object pull We'll set that equal to a new queue. So we just want a local reference to a pull for us to store later. Now we're going to do a for loop. So for int I is equal to 0, if I is less than the pull dot size, we want I to ++. So this is going to be actually spawning all of the objects and adding them to the queue and then adding them to the dictionary. So we want game object obj is going to equal to instantiate pull dot prefab. Now we're instantiating here because we need to spawn an object, but since we're spawning it at the very start, it's not going to lag the actual gameplay. So once everything's loaded in the pool, it'll all be fine. We're also going to instantly set it active. So obj.setActive false. We also want to enqueue the object here. So if we go object pull dot enqueue, and I'll grab the object, and that's about it. After the for loop, if we make a bit of space, what we can do is we can add to our pull dictionary. And what we're going to do is we're going to add our object pull that we've just edited. We can type in pull dictionary dot add. This will be our pull dot type and our object pull. Okay, so we're grabbing the type and we're setting the value to the actual queue of the pull. Now that we've created our pull, I want to be able to make it so we can spawn from the pull. So I'm going to create a public game object that's going to spawn from the pull, and we can access this from other code, and this will actually spawn our objects when we want them to. So I can type in public game object spawn from pull, and we're using a game object because we want to be able to get a reference to the object that we spawn at the end through our other code. So we're going to take in a string of the type, a vector 3 of the position we want to spawn it at, and a quaternion of the rotation that we want to spawn it at. The first thing we want to do is we want to check whether the dictionary does not contain the type. And if it does not, we want to give an error and just completely exit out of this, because we don't want to be spawning stuff that doesn't exist, or trying to, because that will cause a lot more errors. So we can do if not pull dictionary dot contains key, and the key will be type. So the type we put in here, then we can go debug.log, and we can log a warning here. So it'll come up in the editor, and we can say pull with type plus the type doesn't exist. So if you try to type in octopus and we don't have any octopi, then it's going to say pull with type octopus does not exist. And we also want to return null. So we're going to get no game objects from that. So continuing on, let's actually spawn our game object. So we can set our object to spawn equal to pull dictionary at type dot dequeue. So we're going to dequeue the type, and we're going to type in object to spawn dot set active to true, because right now all of the objects are going to be false in the editor, but all we're doing is setting them to true. Then we're going to set their position. So object to spawn dot transform dot position going to equal to the position, and object to spawn dot transform dot rotation is going to equal to the rotation. Now, once we've done that, we can enqueue the object. So pull dictionary at type dot enqueue, and we're going to enqueue the object to spawn. And at the end, we can return our object to spawn. So that'll simply spawn our object. It'll add it to the dictionary, and then we'll return the object, so then we can use it in further code. Okay, so make sure you save that, and we're gonna head back. So now we can create a new script that will actually spawn our object. So we're gonna create C# script, and I'll call this our object spawner. So the first thing I want is a private bool. This is gonna be our spawning object, and we're gonna make that equal to false. We can check whether we're spawning the object or not, and if we are, then we can't spawn multiple of them. Next, we want an instance. So public static object spawner instance, and in our private void awake, we're gonna set instance equal to this. All I want to do for now is create a public void spawn ground. So let's do that. Public void spawn ground. And what this is simply going to do is we're going to grab our object. I'm going to grab our object puller dot instance dot spawn from pool, and what we want to do is spawn the ground. So the type is going to be ground, and the position is going to be a new vector 3, and we're going to put it 0 for the x, 0 for the y, and I'm going to put it at 60f for the z value. Now you might have to change this depending on how big your ground is that you spawn, but I'll show you that in the editor soon. For the rotation, we can just put in quaternion.identity. And that's it. So that's gonna spawn our ground, but we need to make it so we can actually spawn the ground. So let's do that. I'm gonna create another script, and this can be called move component. So we can attach this move component to multiple objects if we choose, but it's gonna be the move component on our ground. So I'm going to set up a few variables. So I'm going to have serialized field, and we're going to have a private float speed. I'm going to equal that to 5f, and we can have serialized field private float object distance. I'm going to make that equal to -40f. Now I've serialized it so it can be edited within the editor if you need. This is just a base value, so we might need to play around with it, but we'll see how it goes. So I also want a private bool can spawn ground. I'm going to set that equal to true. Now in our update method, firstly we want the ground to move backwards, so it gives the impression that we're moving forwards. So we're going to get the transform.position, and we're going to set it to plus equal negative transform.forward, so the backwards vector. And we're going to multiply it by our speed, and we're going to multiply that by time.delta time. Now we can check if our transform.position.z is less than or equal to our object distance, and our transform.tag is equal to ground, which we'll define in the editor. If the object that this component is attached to is the ground, and we can spawn the ground, then we want to spawn the ground. So we can go object spawner dot instance dot spawn ground, and we'll set can spawn ground equal to false. Now we can put another if statement, And this is going to be dealing with making our object invisible once it's out of the screen. So if our transform dot position dot z is less than or equal to, and for this I'm going to be using a float despawn distance, which is defined up here so we can edit it in the editor. And if our position.z is less than or equal to our despawn distance, we're going to set can spawn ground equal to true, so we can spawn another one. And we also want our game object to be false in its active state, so it's not going to be active anymore. Now another thing in our object spawner, I've also defined a private float ground spawn distance. And I've set it so we want to spawn the ground spawn distance right here. So this is going to be our offset. So now in the editor, we can create our ground and our object puller. So I'm going to create the ground first. I'm going to create an empty and I'll call this ground. I'm going to reset the transform. We need to add our movement component, which is cool. I might up the speed a little. And the object distance we'll edit in a second. Now I'm going to create a 3D object plane as a child of the ground, and that's all fine, but it's a little too small. So I'm going to up the scale to be 10. And what we can also do is, if we select player, hold control and select the camera, we can move our player all the way to the end of our ground. So we're going to be moving that way, which gives the illusion of us moving forwards this way in the Z. We also need to add a tag. So add a ground tag, call it ground, and make sure you head back in and set the tag to ground. Now we also need the object puller. So I'm going to add an empty object. I'm going to call it object puller, and we can reset the transform. I'm going to add the object puller and also the object spawner. Now we're going to set our pulls. So if you click on the little arrow, we can change the size to 1, and this is going to be our first object pull. So the type is going to be ground, and it also wants a prefab. So what we can do is create a prefabs folder, and we can simply drag our ground into here. So now we need to drag the ground in, and we also need a size. So I can set that to maybe 5. So in our pool, we'll have 5 objects that we can rotate through. We also want to define the ground spawn distance. What we can do is select the ground, and we can move it backwards until it moves into our camera frame. So as you can see, it's in the frame now. So we want it a little bit offset. So if we set it to something like -49.5 is a nice value. So that will be our spawn distance. So we can set it at 49.5. Now our object distance is fine, and our despawn distance should be okay too. So let's run that. So as you can see, we've got a ground, and it spawns another ground, and once it goes out of the frame, deletes that, and it adds another one. And this is just going to keep going. You can see in the editor, it's going through our cycle of 5 grounds in our pool. What we can do further is we can create a material, can add it to our plane. We also need to apply that. So make sure on the ground, overrides, and apply all. So it gives a bit of contrast. Yep. So as you can see, you can't actually tell that there is a ground moving right now, but that's because our ground is pretty plain. If you did something like added some trees or scenery, or maybe you could even add different grounds to spawn different types of grounds. I will be going through enemy spawning in a future video, and that'll cover the logic that goes over spawning multiple types of grounds, as we can spawn multiple types of enemies. So if you like that video, please leave a thumbs up for another video. Support me on Patreon. I want to thank Benoni's and Joshua, and also please join my Discord server. And apart from that, I will see you guys next time. Thanks.